Lesson 15, Equations of Graphs of Proportional Relationships Involving Fractions. Students use equations and graphs to represent proportional relationships arising from ratios and rates involving fractions. Students interpret what points are on the graph of the relationship mean in the terms of the situation or the context of the problem. Sam's mother has entered a 10K race. Sam and his family want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race with a time of 1.5 hours. Assume Sam's mother ran the same rate as the previous race in order to complete the chart. So create a chart that will show how far Sam's mother has run after each half hour from the start of the race and graph it on the grid at the right. So she can run 5K in an hour and a half. So let's figure out how much she can run each hour. So if she can do 5 kilometers in 1.5 hours, and I take 5 and divide it by 1.5, it is 3 2/3. So we're going to have to use the fraction equivalent, and we're going to have to change it into a mixed fraction or an improper fraction. So it's going to be 10/3. So she can run 10/3 of a kilometer per hour. Okay. So if we know she can run 10/3 of a kilometer per hour, then in a half hour, if we take 10/3, because that's our K, and multiply it by the half hour, we'll get 5/3 or 1 2/3 hour. And in 1 hour, she'll do 10/3 times 1, which is 10/3 or 3.5 kilometers. Hour and a half, she'll do 5 kilometers as it states up there. 2 hours, she'll do 6 2/3 kilometer. Please write all this down because this is how we're getting the answers. And 2.5 hours, she'll run 8 1/3 kilometers. And in 3 hours, she'll run 10 kilometers. And that makes sense because if I multiply 1.5 by 2, I get 3. And if I multiply this by 2, I get 10. So now we got to plot it on the graph. So the first half hour, she goes 1 2/3. So right about there. And the next hour, it'll be 3 1/3. Hour and a half will be 5. 2 is 6 2/3. 2.5 is 8 1/3. And 3 is 10. So let me connect these. So if she doesn't start running, she goes 0 kilometers. So there's our line. What are some specific things you noticed about this graph? It forms a line through the origin. It relates time in hours to distance run in kilometers. The line through the origin means that the values are proportional. What is the connection between the table and the graph? The time in hours is on the horizontal axis, which is also known as our x-axis. This is our x. And the kilometers are on the vertical axis, which is our y. So the coordinates of the points on the, the points on the line are the same as the pairs of numbers in the table. What does the ordered pair 2 and 6 2/3 represent in the context of the problem? So remembering that it goes x comma y, I'm just looking up at the table, and our x is our time in hours and our y is our run in kilometers. So it's going to be, after 2 hours, she has run 6 2/3 kilometers. Organic cooking. After taking a cooking class, you decide to try out your new cooking skills by preparing a meal for your family. You have chosen a recipe that uses an organic mushroom mix as the main ingredient. So now we got to finish the table. So if I want to find my k, it's going to be my y divided by my x. So I'm going to do 4 divided by 1/2. When I do that, I get 8. So 1 times 8 is 8. 16 divided by 8 is 2. So if I had 1, it goes up to 8. So here's 1. Oops. There's 8. And if I go to 16, go over to the line, and then down, it's 2. Is this relationship proportional? How do you know from examining the graph? Yes, the relationship is proportional because the graph is a line that passes through the origin. What is the unit rate for the cost per pound? K is 16 over 2, which is 8, so the unit rate is 8. So that means $8 per 1 pound. Write an equation to model this. Now remember, equations are y equals kx. So we're just replacing the k with what we found over here. So it's going to be y equals 8x. What ordered pair represents the unit rate and what does it mean? So here's our unit rate right here. So we have 8 over 1, remembering that that's y over x. So if I turn this into a coordinate pair, my x is there and my y is there. So what does it mean? It means 1 pound, 1 pound is $8. What does the ordered pair 216 mean in the context of the problem? 2 pounds of mushrooms for $16. If you could spend $10 on mushrooms, how many pounds could you buy? So I'm going to use the equation, and we know that the dollars is our y, so I'm going to put that in. For y. Now, to find my x, I got to divide each side by 8. So 10 divided by 8 is 1.25. Oops. 1.25 pounds.